Ever since completing my research for this episode, in fact I have only one question. Is it even a database anymore? Stay with me and I'll show you how PostgreSQL can replace all your backend stack components. After more than 35 years of active development and a new release coming every year, PostgreSQL today is the most popular and, according to its website, most advanced open source relational database. If we look into the latest Stack Overflow developer survey, it's also the most loved database among professional developers. In the list of companies using PostgreSQL in production, there are many household names. Every major cloud provider has a managed PostgreSQL database service. But unlike all the competitors in the pretty crowded database niche, there is no single company governing development of PostgreSQL. There is no king like Linus Torvalds, Mats or Guido van Rossum to approve technical decisions. The official roadmap page even claims, "We enjoy allowing developers to explore the topics of their choosing." Sounds like a product owner's nightmare.
Scrum? Yes, Scrum. Scrum.
So what PostgreSQL really is and how come it is so successful? Database project with an elephant mascot was not always considered cool. Just look at these Stack Overflow developer surveys for the past several years. Back in late 90s and 2000s, every web developer knew what LAMP acronym stood for. Linux, Apache, MySQL, PHP. MySQL, an open source database from Sweden, became a go-to storage solution for booming internet businesses. It was free, it was easy to set up and work with, and it was fast. Facebook used MySQL, Twitter used MySQL, YouTube used MySQL. PostgreSQL project at the time was focused on painstaking implementation of more features, better compliance with SQL standards, query optimizations, indexing improvements, crash recovery, the list goes on. It was clear that its contributors followed a very different philosophy. Instead of speed and ease of use, the key selling points of MySQL, they wanted to build the most feature-rich and standards-compliant database in the world. So how feature-rich is feature-rich PostgreSQL? The official website calls PostgreSQL an object-relational database. What does it even mean? The idea is to bridge the gap between object-oriented concepts with object hierarchies and complex data structures on the one side, and relational database design where you have only tables, rows, and columns on the other. So how does this fusion of two worlds work in PostgreSQL? First of all, you are not limited by native data types, although even here you can feel what feature-rich means. In addition to common numeric, Boolean, and character types, PostgreSQL supports right out of the box several ways to store datetime, a bunch of network address data types that allow for quick subnetting calculations, and, for example, geometry types like polygon or circle, to name just a few of supported native types. But because, as I said above, PostgreSQL is an object-relational database, you can as easily define your own types and use them as if they were built into the system. Let's say I work on role-playing game and I want to store game characters in the database. Let me define the character type. This is how I can create a table and use my new custom data type there. Here's the game character. This is how I can query my characters table. Okay, let's go back to object-oriented concepts. You've seen complex data structures, typecasting, and the dot notation to access object properties. Another cornerstone object-oriented concept that is implemented in PostgreSQL is inheritance, table inheritance. For my role-play game example, let's say I want now to have a table for NPCs. NPCs are special characters that always have a quest to offer to a player.
I trust you have a good reason for interrupting me.
Which means I can inherit my new NPC table from the already existing characters table. Time to populate it with a couple of NPCs. Pay attention, fields character ID and character are not defined in the NPCs table, they are inherited from the parent table. Here are my two NPCs in the NPCs table. Now the interesting part, all three game characters, two NPC players and one player character, are now stored in the parent table. Let's not forget that object-oriented programming is code and data bundled together. When it comes to running code in the database, PostgreSQL has to offer more than any of its competitors. Just look at the table of supported programming languages for stored procedures. Before I can go straight to the code, I need to enable the language handler, and for that I need a package manager. Yes, there is a package manager for PostgreSQL extensions. This is the code of the stored procedure. I've inserted some test data for it already. Let's see. With object-oriented features of PostgreSQL and the power of stored procedures, your database is not a dumb storage anymore, and you can actually set your backend application free from data logic. As this gentleman shows in his blog post, things like user management, which is data logic, can be fully self-contained in a database. With help of PostgreSQL extensions, you can hash passwords, generate JSONB tokens, QR codes, anonymize personal data, render HTML from templates, and much, much more. There are 3 different actively developed HTTP clients that work entirely within database context. The more I learn about PostgreSQL, the more I come to a conclusion that it has extension points everywhere. This extensibility is the feature of features that makes PostgreSQL so universal that it can, in fact, replace your whole backend. So now let me show you how one database system, one software product can replace a whole technological zoo of typical backend project. Shall we start with caching? It's fairly easy to build a key value store on top of PostgreSQL. I would like to have expiring values like in Redis, so let me install a pgcron extension for that. Now to the database. Another popular Redis feature pops up, can be replaced by built-in notify listen commands. As you may expect from a relational database, notifications can be wrapped in transactions. And of course, you can create a trigger which will send a notification whenever, say, a new game character is added to the characters table. Since we started with messages, how about replacing your message queue with PostgreSQL? pgmq operates similarly to AWS Managed Message Queue in Service SQS. It ensures exactly once delivery by temporarily hiding recently accessed messages. Engineers from Prequel, a company that facilitates cross-database synchronization, have replaced the popular message broker software RabbitMQ that served their backend job queue with just a PostgreSQL table. Row-level read-write locks ensured that each job was picked by a single worker. The goal was to make their infrastructure simpler and easier to reason about. We'll come back to this idea later in this episode. Next candidate for replacement in my list is MongoDB. To begin with, PostgreSQL supports JSON data type natively. The query syntax may look different from JavaScript-esque Mongo syntax, but hey, all the cool NoSQL databases out there after being around for at least some time are all adapted some kind of an SQL-like language. Look at, for example, InfluxDB, Couchbase. So moving to the real, standards-compliant SQL is a good thing. There is something about this technology that makes it so resilient and future-proof that even NoSQL vendors understand that they should at least mimic the structured query language. If you decide to move your JSON documents to PostgreSQL, like for example Guardian did, you will need more disk space, because there will be no document keys compression like in Mongo. But then again, you will get out-of-the-box integration with everything else PostgreSQL has to offer, and of course, less infrastructure to maintain. What about other types of NoSQL databases? You can turn your PostgreSQL into a graph database with Apache AGE project and use both SQL and a graph query language OpenCipher to model, store and analyze connected data. For example, you can map relationships in social networks or track connections within power grids, things like that. For time series data, there is TimescaleDB, an extension designed to efficiently handle timestamped data. so that you can, say, monitor IoT device metrics or maybe analyze user activity logs for web services. TimescaleDB works nicely with Grafana, by the way. If you have a bunch of text data, though, oftentimes you need to search through it, not with like statement in SQL, which is pattern matching, but in the way a search engine does it, with stop words, word stemming, and ranking of search results. That is, the search should find results with similar words and sort them accordingly. In a typical backend setup, this functionality is covered by ElasticSearch. ElasticSearch would continuously get the data to index from somewhere else, maybe from a PostgreSQL database, and provide a standalone search service. But if you choose to integrate PostgreSQL's full-text search capabilities, you can achieve similar functionality directly within your database. Given that you wouldn't have to synchronize data for search, you will get an always up-to-date index. And as with all the examples above, your infrastructure will be simpler and therefore easier to maintain. Of course, you should mind the constraints, but for many, maybe even most, projects out there, running an Elasticsearch cluster for full-text search is an overkill. When it comes to text, of course you cannot get around LLMs, large language models. Imagine you can query an open-source LLM model. Imagine a chatbot running entirely on the database side. Here you go. You need a machine with a GPU and a pgml extension. Okay. So you ditch the message queue and a whole bunch of NoSQL databases, replace them with PostgreSQL. You can now search through your data in near real time and run machine learning models right within the database. Now what's left of your backend stack? The API itself. Postgrest is the web server that turns your database into a REST API. In a typical web framework, to add a new entity, you would have to prepare database migrations, define a data model in some kind of an ORM, and then configure API endpoints. In many cases, the code will just wrap around simple CRUD operations to create, update, delete a record in a database. With Postgres, instead, you just need to create a database table. That's it. Postgres will take care of authentication and authorization using PostgreSQL's own role-based access controls with role-level granularity. To go beyond simple CRUD, as you may have guessed it, you got to use stored procedures. Within stored procedures, you can of course leverage object-relational nature of PostgreSQL and all the extensions I've mentioned before: PubSub messaging, message queues, key value, object, graph, and time series data stores, as well as full-text search and machine learning functionality. And yes, you can unit test stored procedures just like you would do with your web framework. If instead of REST you'd rather prefer GraphQL, you're covered as well. pgGraphQL extension creates a transparent mapping between your data in PostgreSQL tables and GraphQL entities, so you can run GraphQL queries using a single function call. If you couple pgGraphQL with Postgrest, you can run GraphQL queries over HTTP. By now, you probably have no doubt that PostgreSQL is in fact a platform. Omnigres project took this idea to extremes, going as far as managing containers, storing files in S3, and even providing payment support, all within PostgreSQL. Regardless if you want to go all in with Omnigres, or just make your backend infrastructure a bit simpler to maintain and reason about, PostgreSQL is on your side. It's not only as feature-rich as you can imagine, but also enterprise-grade reliable. Think about it. Maybe you don't need another shiny document database or a search cluster. Instead, adopting boring technology and embracing radical simplicity might yield long-term benefits for your project. Besides that, improving your SQL skills seems to be a very future-proof investment. And while you're getting used to the idea that PostgreSQL is not a database, I'll play Doom right in my SQL client.